Hello everyone, it's great to be back with another version of our software. COMOSYS is getting more and more mature as a product as time passes, and we work very hard to ensure you get something new every few months. We work hard to make it a smooth transition for those of you who are genuinely looking for an alternative, which is both capable and affordable. Today, I'll be sharing with you what we have added in the last 6 months. We were together in January, and now it's July. We hope you will enjoy, and we hope every new feature we add brings you a little bit closer to the decision of migration. So, without further ado, let's get into it. If you have any questions, please write them in the Q&A area, and we will try and address them at the end. One very nice feature which we have implemented in this version is related to the bolted gusset macro, which all of you enjoy because it is one of the most powerful macros in COMOSYS because it caters for so many different situations. One such situation is when you want to have a gusset plate connection, and this is the capability which we already had with two plates on. Let's say there's a pipe coming in and there's an end plate, and from the end plate you could um, have two different plates coming out, and then they would be bolted to the gusset plate. Now this is a very good connection, very compact, but it has problems in the field, in that the actual installation of these braces, especially if there's two of them, becomes difficult because you need to slide them in from the side because of the two plates on both sides. And making a connection with just one plate is also not something which is preferred. So we want the two plates on both sides, but you also want to ease the process of installation and erection. So in this version, we have added a few parameters which are very, you can see on the first page over here, down here, which is the double-sided loose plate option. Now, what this does, let me just do it for you. If I select this option now and I say apply, you will see that you get a different kind of a connection now, in which you have these two, previously these two plates on both sides were actually welded to this end plate. But now instead of that, you have one plate which is welded to the end plate, and these two plates on the side are now actually loose plates, which puts extra bolts in there. Of course, that's the downside, but it really makes the installation of this brace at the site so much more easier, especially if you've got large braces. Then this option is really a game changer, and it makes the installation or the erection at the field so much more convenient. But that's not all. We've actually created a modified version of this connection as well. So in this version, if you see, the end plate is quite thick, and the reason because it's thick is because it's transferring all the force into the bracing from there. But if we extend this, if we choose this option over here called the extend the loose plates, then what we get is, if we just say apply, you will see that we get a different version of this connection. And in this version, the green plate which is coming out is actually being extended into the pipe, and you can define the distance how much it will go in. But now you see that the end plate is actually just becomes a cap plate because it's lost all function structurally. But this green plate is now gone inside the pipe. It's cut through the pipe and it's going to be welded to the pipe, and all the force will be transferred through the green plate along the weld and then through these loose plates. So the issue of the difficulty of erection has been solved, and also this end plate, this risk of the end plate being a weak point, has also been solved in this way. So very convenient, very powerful connection, and we hope you will enjoy it. And the macro will not just work for the pipe profiles, but if you have a rectangular or square hollow section, then once again you will have this option of the loose plates double-sided with the welded plate either extended into the bracing or directly welded to an end plate, as we saw in the. So for example, if I were to change this option over here, bring it back, then we'll get a thick end plate, and the other connection will be made as shown. Another macro which we've added is what we call the end plate splice. Once again, there was one macro called the end plate splice before as well, but this one has some new options. So let's just try them. When we select the two I-beams, you get this kind of an end plate connection. And what's new over here is that you now have the option of adding shim plates between them as well for ease of erection. Now, so if you go inside the macros user interface, you will see that you can turn on the creation of shim plates, and this shim plate is actually calling the other shim plate macro. So you can specify how many plates you need, and you can also specify what kind of shim plate you want, as you know from the other macro. Now, another feature which this one has is the flush plates option, which means that previously we could not create this end plate splice. So let me just turn this on like that. Now you can see that the plates are now flush with the profiles themselves. And this kind of a connection is needed a lot because you might have some obstruction over here or some other things passing from that point, and you don't want these plates to be coming out. So with this new option of creating flush plates, and of course you have full control over the stiffeners and everything, and the bolts, but with a simple click you can convert it into a flush plate, and this really becomes useful when you're doing your modeling. Now, the same macro will also work with pipe profiles. So if I go in and I select two pipes, you will once again get your end plate connection once again with the shim plates, and once again, but in this case, of course, using the flush plates option is a bit meaningless, but you have that option basically for the I-beams. If we do it for the same macro will also work for rectangular or square hollow sections, and you have control over these stiffeners. These stiffeners can be copied on both sides like that. If you go inside the macro, you will see that the top stiffeners and the side stiffeners, and you've got these positions options over here, and you can enter different numbers and you will create as many stiffeners as you want. But the real advantage being this flush plate option, which will allow you to. So if I do it over here, even it will do it in the case of the rectangular hollow section. Of course, this would require you to create holes over here because there's no accessibility to those to the bolts inside. But if you wanted to, you could create holes from the sides and make it accessible, and this would become a useful feature to have. Checkered plates often require toe plates around their edges. This could be when you have openings in them, for example, or areas where you don't have a handrail. You want a toe plate around them. So although this is doable with manual detailing as well, it's always good to have dedicated tools for these things. So, for example, we have developed under the ancillary steelwork menu these three commands over here, which allow you to create toe plates for various situations commonly found. So there's one which is the edge toe plate, which works like this, that you select a checkered plate or any plate basically, and then you show it some edges where you want the toe plates, let's say these three, and then you right click. And when you right click, immediately what happens is it's going to create these toe plates, and you can modify the parameters, you can modify the thicknesses. For example, if we go inside, there are two different types. You can either make the toe plate sit directly on top, or you can weld it from the side as well. And you have control over the distances from the start end offsets. For example, if I were to give a start offset of, if I were to say 1 0 0, that would mean the first plate has an offset of 0 and 0 all along the wedge. I could give other numbers as well. For example, if I were to do the same thing on this plate, but I only wanted the toe plate in a limited area, what I could do is I could select this one and select the edge, right click, It'll create the toe plate all along the thing, but if I wanted to, I could just go inside and give a distance of uh, something like one. One would be in the first toe plate, and then around maybe 1400 and 1400, so roughly about that number, to bring it in. So maybe this one needs to be a bit bigger, or the other one, I'm not sure. Yeah, something like that. So you can calculate the offset which you require, and then you can give the offset. We could continue with the third one, like that, and this edge over here. Right click, and now although we don't have handrails on this side, we've managed to create very quickly these toe plates, which will not only stop things from falling down on the other floor, but can also be used for as formwork as well if needed. Now, another situation could be when you have a hole, you want to have something is coming out. Let's say there's a pipe coming out from the middle of checkered plate. You could go in and use this particular tool, which is a polygon. You can create a polygon opening in the checkered plates. So what you could do is you could click these points. Let's turn on. Let's snap to the point at the back. I'm trying to create a rectangular hole, and then you right click, and then you show the checkered plate, and right click again. And when you do that, you have basically created a hole with the toe plates around it. So similarly, there's a third one for creating circular holes around multiple checkered plates as well. So these are very useful, very powerful, because I mean, even doing something like this manually would have taken at least 10, 15 minutes maybe. But in this way, it's having the macros available, it's much, much faster. Now, the good thing about this tool is that it also welds these toe plates to the checkered plate. So if I would say select assembly, you can see that the whole thing is now become an assembly. Similarly, if I would select this one, say select assembly, you'd see the whole thing is now an assembly. You could use it all around, like I said, to put a toe plate on one side of the thing, but also on these small areas. Sometimes you have a requirement where the handrail is not continuing, let's say, and you just wanted to cordon off that area. So very useful, very handy tool. You can create. If I were to select this particular checkered plate, say select assembly, you see the whole thing is selected. Similarly with that one. This one rather, if I say select assembly, the whole thing is selected. So a very useful tool which will allow you to model checkered plates very, very quickly. There's another tool over here for circular openings. For example, if I were to click on that and show it a center point, and then show it multiple plates, say this one and this one and this one and this one, and right click, it will create toe plates around each one. So if I select this one, this is a separate assembly, that's a separate assembly, and similarly the others are. So what it does is basically creates these rounded toe plates, which are create. I mean, you can do this manually as well, but this way it's much faster. Now imagine a slightly different case. For example, if the geometry of the plates was different, it would still be able to, if I select this center point and went through the four plates like that, it would still be able to find out exact where the toe plate would need to end and create it accordingly as shown. So like I said, a handy tool to have. If you're doing a lot of checkered plate modeling, this will be useful for your company. One nice tool which we have created with this version is the ability to create nuts and washers and bolts in any configuration, which, for example, you might be needing to use them as anchor bolts. So you have the ability to create an anchor bolt with any length and whatever arrangement of nuts and washers on both sides. And the way it works is that under the bolt command, there is something called creates washers and nuts, and actually it's create it means create bolts and washers and nuts. So if you press on the shift key, it'll open up the dialog box. And over here, you have the ability to select the bolt standard, the washer standard, and the nut standard. And these are all linked to the database. And once you select these standards, you can then choose the bolt diameter, then the washer diameter, and the nut diameter, and it'll fetch all the lengths of that bolt. So you can add anchor bolts to the bolt database of whatever lengths which you want and whatever diameters, and you can even create separate standards for them. You don't have to use the existing standards. Once you do that, then they will appear in this list, both the bolts and the washers as well as the nuts, and you just need to choose them. And then we have given you a format uh, with which you actually define the location of the nuts and the washers and everything. So it's B means bolt, N means nut, and W means washer. So with this coding, and any number which you put in basically is a gap. So when I say B20, it means there's a bolt with then there's a gap of 20 millimeters, and then there's two nuts after that, as you can see, and then there's a washer, and then there's a gap of 650 millimeters after that, and then there's another washer, and then there's a nut. And you can create, of course, multiple copies of multiple definitions, and you can create a thread on both sides if you want. So there's a thread on the other side, and you can give that, and you can modify the. These numbers are all taken directly from the database. And once you have this set up in your database, it's very easy to use. You just show it a point, for example. So if I were to go into my command right now, I'll hover over this. It works in the negative Z direction. Sorry, it works in the positive Z direction. So it's a good idea to first place your work plane in the negative, so that it points downwards rather than upwards. And then all you need to do is you need to just hover over a point and say however much the projection will be from that point. So it's 73 millimeters in my case. And if I just say that, you will immediately create a an anchor bolt at that point. Very easy to use. Just like I said, you just hover over the point and you create an anchor bolt. Once you do this, it will be very easy to create drawings of these anchor bolts, and because there will be even the threads will be shown on the drawings, you can dimension them. So for example, if I go to the drawings right now, you can create, for example, a drawing like this, in which you will be able to snap to the thread points on both sides, and the nuts and the washers and everything. So it's a very convenient tool to which you can use when you're modeling anchor bolts. The beauty of this is that you can create as many different types, store them away in the database, and then just recall them and give them any length by using that special coding which we talked about, this particular one, which allows you to put any gaps in between them and place basically anchor bolts anywhere you want. You can also use it just to place nuts and washers anywhere. You don't have to put a bolt inside. You can just say create a nut and a washer and a nut at any point that you want. It's going to work according to the current work plane. So it's basically a handy tool for preparing items or create modeling items in your bolt database. Another handy little macro which we've added for you is under the beam to column connections. It's called the hollow section end plate. And you have situations where you have elements coming from both sides. And although the name implies hollow section only, but it actually, I'll show you, it works for most sections. So this is an I-beam, and it's got square hollow sections coming from both sides, one sitting on it, one under it, like a column. And if I were to click on this and select the main beam first, and then select either one, whatever order, you will see that it creates an end plate connection, double-sided, with the stiffeners in between. So very conveniently, with just a few clicks, you can create this connection. You could have done this using other options in a couple of steps before, but now you can do it directly. Now, this doesn't necessarily only work with hollow sections. If you had a channel sitting on it and it was one-sided, you could still go like that, and the channel would be connected. The stiffness you can control whether you want to create them or not, but usually when there's a point load sitting on a beam, you would need the stiffness. If there's an angle sitting on a beam, once again, you could use the same macro. If there's a pipe sitting on a beam, once again, you could use the same macro. It could be both sided. So if these are angles on both sides, so if it was like that and like that, once again, you could create it. A box one-sided, once again, you would be able to do it. And the orientation doesn't necessarily have to be in this vertical direction. You can use the same macro either single-sided or double-sided, even laterally. You have control over the way the bolts will be placed. So a handy little macro used. You can have many situations where you might need it. It'll create the stiffness. It'll create the end plates on both sides, and it'll work with most sections. So quite a useful macro to have. The next thing I want to show you is related to the PEB sector, where tapered frames are created using plates. And it's not just three plates, one for the flange, top flange, one for the bottom flange, and one for the web. But because they optimize the building as much as they can, you will see a lot of the flange changing thickness, the web changing thickness within the same element, and then you get details like the differences in the thicknesses everywhere. And what was being requested from us was the ability to create a tool which would give you the ability to, just like you're entering a frame, a column or a beam. In the same way, we need a tool which will allow us to enter the frame, but with multiple plates for the top flange, multiple plates for the bottom flange. They could be staggered. Multiple plates for the web. Once again, they could be staggered, etc. So this is what we created for you in this version. Now, I won't spend too much time explaining the entire user interface, but you have the ability, there's a general tab, there's a flange tab for the flanges, and in the general tab, you're able to define up to 5 different web plate thicknesses at various heights. You can choose the number of points you want for the web heights, and then each one, when you change that, this picture will change, and you will get different. You will be able to input these various heights. And similarly for the flanges, once again, you have the upper flanges and the lower flanges, and for each of them, you can have up to 5 different thicknesses and locations. So like I said, you can stagger these flanges. They don't need to be at the same point. So it's a and it also creates the welds for you between, if you want to. It's optional, but if you want to, it can create the welds between the web plates and the flange plates. And it's extremely the way of entry is very simple. You just basically select 2 points and you get the whole thing. Now, the way you enter these elements is just like you're entering a beam, basically with 2 points. So if we go, so it slides under the structural members over here. It's called the built-up tapered frame. And when you click on it, it'll ask for 2 points, even for the column and for the beams. So I'll click on this point, and the height of the column is 8 meters. So I'm going to say DZ 8000, like that. And it's going to create a default column for me. I can go in, I can have saved presets. I can load my column preset like that. And it's going to change all the numbers, of course, all the heights and the flanges and etc. And if I say OK, basically I get my column. And you can save this away for different shapes. And every time you need to make a change, all you would need to do is just go inside and just change these numbers a bit so that you get the same format. For example, for a different preset, if you wanted the web to be tapered and then straighten up, you would create a preset for that, and you'll just use that again and again. But like I said, it's very powerful. You can basically do whatever you want with it. If I wanted to enter the beam now, I would snap to this point. The height is 12 meters over there. So I'm going to hover over that point and say DZ 12,000, like that. And then I'll just load my beam preset, like that, and there you go. So it's a very handy tool for creating tapered members with plates. And like I said, you can stagger them, you can create multiple plates, up to 5 plates, and that will allow you to basically create any kind of a tapered member which you want. We are targeting in the coming versions many more macros which will also work with directly with the plates. So you will have a complete PEB solution from within COMOSYS. No need to go anywhere else. Now, in the real world, macros will only take you 70, 80, 90% of the way. And they'll always be a part of the project which you will need to do manually. And this is where you need to improvise. This is where you need to use tricks and clever ways to do modeling. And now I'll show you some of the things which we developed, which will help you use these little tips, these tricks, and get your work done. For instance, here is a situation where the bolted gusset macro won't work because this incoming member is not only skewed and moved up, it's also rotated, and it's not going to work with that beam. If I tried it, if I selected this is the main and this is the secondary and right click, nothing happens. The macro doesn't work. Now, one thing good detailers will do is they'll create another member over here and use that to make some sort of a connection and then modify that connection to meet the requirements. And the only time consuming part is actually creating that member, creating that main member for which, with this orientation, the macro will work. So we've added a little tip, a little trick, which all you need to do is put the work plane on the secondary, and that you can do by just selecting it and saying work plane to object, like that. And then, so this is the end point. If I were to go to the beam command and hover over this point and say, so this being the green direction being the Y direction, which is the direction I want for the beam. If I say LY 1000, it's going to put a beam 500 to the left and 500 to the right of that secondary member, like that. Now, it might not be in the perfect position, it might not be the perfect profile which you want, so you can just change the profile like that and press Control W to bring it in front of it. But this is now oriented in such a way which is it's oriented according to that. So this little thing which we've added in the direct entry method is very useful. You just hover over the point and you say LY or LX or LZ, any one of those. You can create a temporary member left and right of it, which you can then use to make the macro work for you. So let's do that. Let's select the bolted gusset, use this one as the main now and the secondary, and right click, and we see that the macro works because now this one is oriented correctly. And now we can do the modifications which we want to do. So I don't want these pink stiffeners at the left and right. So I'm going to go in and say I don't want them, like that. And I'm going to pull this back a bit. I'm going to put a number about 200, like that. I kind of pull it back, and I'm okay with that. And now what I can do is I can select this plate, click on M for the macro, right click, and explode the macro. And once I've exploded the macro, I can select the beam and get rid of it. Now that I have some sort of a gusset in there, I can of course select that gusset, and this is the edge actually which needs to be aligned with the web of the main. So I'll just select that edge, go to my move edge to surface, click on the select surface, and just show this side of the web, like that. And immediately I've got some sort of a usable gusset right now. Now, if I select it once again, I can see that there are two close points over there. Maybe I don't want this point, so I can select this and just click on the minus button. And now I've got a fairly useful gusset. Now this is where the first trick which I showed you, which we've added in this version, is using the direct entry LXLY, which creates a temporary member in either the Y direction or the X direction or the Z direction, and then you can use it to temporarily connect and then explode. And now what I'm going to show you is how you can actually, there are some other handle features which we have added to this particular version as well. Now, for example, this one, this line, I want this line to be coming out perpendicularly from that face of the web. So what I can do is I can select this edge like that. And if you notice, we've added a few more options over here. This one is perpendicular to surface and this one is parallel to surface. So if I say perpendicular to surface, and then if I select a surface, I can show it the web to which it needs to be perpendicular. And then it's going to ask me which point do you, because there are 2 points on this edge, this one and this one. It asks me which one I need to keep constant. So if I click on this one, it's going to move the other one. And if I click on this one, it's going to move that one. So if I click on this one, see what happens? That gusset now becomes perpendicular to the web over there. And I can use the same trick because if you remember, we deleted a point over here. So this one is not coming out perpendicular as well. So I can select this edge now, say perpendicular to surface once again, select the same surface, but this time I want this point to remain the same and the other one to change. And we see that we have created a gusset very quickly, which is beautifully aligned as if the macro had worked in this situation. So these are very useful little handle tricks which we've added. You can just select an edge and you can make the edge either go perpendicular to a surface or become parallel to a surface. And in each case, you will show it one point, either this one or the other one, the one which you don't want to move. And the other one will move in such a way that the edge becomes either parallel or perpendicular. These two new options have been added in this version. And with manual detailing, these kinds of little options are extremely powerful to help you get your work done. And say you wanted to put a stiffener, if the fact that the gusset is hitting the web is bothering you and you feel the web will be too weak to take the force, and you wanted to put a stiffener at the edge over here, but it's an inclined, complicated thing. Once again, the macro doesn't work over here. What you could easily do is just create a plate on the surface and choose this end surface of the gusset like that, and you'll create that little small plate. Just select it, take the bottom edge, and say hit the bottom surface of the or the inside of the bottom flange like that, and take the top one and make it hit the underside of the top flange like that. And if you wanted to play around, you could make, so this is one of the other things which we've added over here. If I were to select this one and I make it say 90 millimeters, and I want the pink handle to move back, not the yellow one, I'll just click on the pink handle and it'll be shortened. So if that's not enough, maybe I can just double click on this and see the size. So the width is 180, half of that is 90, and then you reduce the width. So maybe about 70 would be good. I can click on that and make this 70. And once again, I can click on the pink handle. So it goes in. And then I can maybe click over here and make this one, whatever, some number. It's inclined. So this time I want the yellow one to move in like that. So we're using these little tips and tricks. And now that I have that, I can see that the inside edge is not hitting the surface of the web. Once again, I can just go like that and like that. And I have a little stiffener in there, which kind of works. Or if I didn't like it, like I said, I could move this this one back to a bigger number, maybe 70. Move it in the yellow direction like that. Yeah. So these are little tips and tricks which we've added. The perpendicular option, the parallel option, the creating of the temporary member using the pink every time you select one of these edges, now if you can see, they're color coded. There's a yellow side and there's a pink side. And if I just clicked on this one and wrote a different length, I can make that length go in the pink direction or in the yellow direction. Now, this was possible previously as well, but they weren't color coded. But now with the color coding, it was a bit of a trial and error. So now it's a lot simpler. So these are little tips and tricks which will help you in the manual modeling phase. And like I said, that manual modeling is inevitable. Macros will only get you 60, 70, 80%, 90% where you want to go, but there'll always be a little part of the project which you need to do manually. And if we wanted to continue on the other side, once again, we could just put another plate on the surface like that. It's very, very simple. Just click on these handles, bring that one down, move it to the other side, bring this one to the underside of the web like that. Select this one, take it to the web like that. And once you've got the basics in, just select this one, make it 80, and click on the yellow one, click on this one, make it 80 as well. And this time click on the pink one. And you see how easily you have a stiffener. And if you wanted another stiffener in the middle over there, you could perhaps just use this, select this face and then this one, and you can get a stiffener in there as well. Now, all these little tips and tricks we've added, like I said, will really help you create complicated connections. So you can see this is a pretty complicated connection in the sense that everything is inclined, rotated, skewed, but you see how easily we've managed to create it. Now, IntelliClone is one of the most loved features in COMOSYS, and in the previous versions, we had the ability to clone plates and bolts and welds and cuts and macros, but what was missing was the ability to clone generic solids as well. So, and of course, generic solids can be needed in special situations. So, for example, here is, you can imagine this to be a handrail component in which there's a handrail post and an inclined handrail coming in, and they're connected with these generic solid components which I've created with the shape editor. Now, if I were to just go in, if I made one of these connections, and if you notice there are other places in the model where the connection has not been applied yet, if I were to just go in and select like that, making sure that my node is selected, and it says there are four which are also there. If I say clone to all, there it says there are three more which are unconnected. And if I were to say proceed, you will immediately see that the other joints have been cloned with the same connection as well. So this was something which was missing in the previous version, the ability to clone even generic solids across your with the IntelliClone command, and now we've added this. So we hope this will be useful for everyone. Now, concrete is an interesting material, and you can give it any shape which you want. That's one of its unique features. But this also leads to detailers being carried away with the kind of rebar which they place. And of course, this is a very simple, not very complicated shape, but you will see detailers sometimes producing all sorts of very complicated rebar shapes, which are not really practical. And there's a reason why codes kind of limit you or want to limit you to certain shapes. And it's a good idea to remain within those shapes. And these shapes are pretty simple, usually straight bars or L-shaped bars or U-shaped bars, and the stirrups and cross ties and all that. So having very irregularly shaped bars can create problems in the at the site. So it's always a good idea to remain within the shape codes. And therefore, we have, while we are allowing you to model any kind of rebar which you want to, we've provided a rebar catalog over here. And this kind of allows you to, first of all, see what the codes will allow you. So you have a standard which you can select, and if you move down, you can see the different shape codes, and you see they're pretty simple shapes most of the time. And this will remind you of your limits where you need to stay. And if you are the type who actually likes to be very very careful, then you can even use this rebar catalog to actually create your rebars and then modify them. So, for example, if I wanted to use the rebar catalog, I could put my work plane somewhere, go to my rebar catalog. For example, if this is the shape code which I want to create, I would basically just click on the create button, and you see in the background the rebar of that shapecode has been created. And then if I wanted to, I could select the points and actually modify them according to whatever. So if I were to select a surface over here like that, I could extend the rebar like that. I could click on this point, select the top surface of the slab, and once I've got my rebar ready, I can click on it, right click, say inquire, and I can see that it belongs to a particular shape code with all the A, B, C, D parameters given over there as well. If I were, on the other hand, select this randomly looking rebar and say inquire, you would see that it doesn't have a shape code and the ABCs are not defined. So just as a precaution, one can always work like this with the new features in COMOSYS as well. Now, previously in COMOSYS, the rebar bar sizes were in millimeters, and since the US imperial environment works with different bar names, and they don't really have the names in terms of even in inches, but it's more like number 3 bars, number 4 bars, number 5 bars, like that. So we've added the option of defining your bar names in the available steel diameters file, which is under the preferences menu. And there you can have a column with the bar diameters, and then another column for the bar names, and whatever bar names you put in there will turn up in your macros, in your all the container macros, the surface macro, even your parametric macros. For example, if I open up this one, you see that now instead of the bar diameter, you have the bar names which you can choose from. So this is a useful feature to have, and you can easily, if and even the dialog box of the bar itself now, instead of having an edit box over here as it used to have, now has the bar name only, and you can just, all you need to do is just choose the bar name, and everything else is also now converted into imperial units. Now, of course, interoperability is um, is a never-ending requirement, and softwares need to talk to each other. Files need to be converted, and we realize the importance of this. And we, in every version, we try to add a few features, improve a few features. In this particular version, we have added the capability of importing STL files. We previously had the export only, but now you can import STL files into your model, and you can also import OBJ object files into your model, which you can then snap to and work with. So if we were to do an example for that, you have the ability to select a file, and then you have the ability to give this a scale, and it will bring it to wherever your current work plane is. If I were to say import, for example, I just imported the simple model of the Eiffel Tower, and you could, in a similar way, import other STL files and OBJ files to work with. Cold formed steel with purlins and girts created as cold formed elements is very common in the steel industry, and particularly so with PEB, pre engineered buildings. And as you can see, with this new version, we've added a lot of new sections which you can now use inside COMOSYS, both directly from the database as well as in parametric form. So we already had the Z profile, of course. This one was there, the unsymmetrical Z with this flange width different from this one. Now we have this, the lip is at an angle over here. The sigma cold formed is there. Then we have now added this one with the top flange sloped and the lip perpendicular to that slope, like that. And then there is another one in which the same slope exists, but the lip is actually vertical or aligned with the bottom lip. Then you have this profile now available with the double lip at the top and the bottom. Then there is this one available now, like that, in which the lip goes in the other direction. And then you have the unsymmetrical one as well, where the flange widths of the bottom and the sloped top are or can be entered differently. And like I said, all of these are available in parametric form as well. So while you can put them in your databases, you can also directly, if you hover over this, you will see the hint for that. You can directly enter them using the parametric versions as well. Now, steel and concrete detailing is not all about beams and columns. Sometimes there are weird shapes involved, and all sorts of difficult geometries might be involved. So, in this version, we have developed, we had lots of parametric solids previously as well, and these are very advanced features for those who are using them. But we have added another one, which is also very useful, which is called the lofted plate, which basically allows you to loft a plate or a surface between two polylines, if you will. So you see these two lines over here, they're actually crossing each other, but they're not on the same level. They're not, the one is at 0 level and one is at that on a higher level. And if I were to use the lofted plate command between this line and this line, and then say right click, you can see that it's created a lofted surface like that, which will then allow you to, if you want to model something on top of this, if you want to model plates on top of this, or use this as a base, all that will be possible using the lofted surface or lofted plate command. Now, these were lines. This one is more complicated. This is a polyline with a chamfer in between, and there's another one. If I look at it from the top, you can see this is the one at the 0 level, and this one is at a higher level. If I were to rotate this a bit and go to the lofted plate command and select this one and right click, you can see that this lofted surface is created effortlessly. And the command is not limited to just selecting two polylines. You can select multiple polylines and it will just basically follow them by creating lofted sections one after the other, and it'll all become one object. So if I use 3 lines, 4 lines, 5 lines, the whole thing will become one object. So very useful command if you have difficult shapes to model and then you want to work on those polygons, because it basically creates the polygons for you and now you are able to work with them. So very nice feature to have. A nice option which we have added to the drawing side is a new section symbol, as you can see on the screen. This one is a different format basically. So when you're using your section commands to create sections or just section symbols, you can now have this option of this is called type 7 now, style 7 rather. And in the style 7, it creates a circle on one side and creates an arrow on the other side. And on this side, you can write the text of the section as well as a secondary text. So you can write anything over here. It could be a reference to another page sheet, for example, and it has its own font size, etc. So you have control over the font over there for the secondary text as well. And you can place this section symbol on either this side or the other side. So if I were to change this from right to left, then the symbol goes to the other side. So this was something which is used quite often with drawings, and this was being requested, and we've added this in this particular version. Now, drawing creation is one of the trickiest parts of steel detailing, and you run into all sorts of requirements. For example, sometimes you have an assembly which has both very large plates welded to it as well as very small plates welded to it. And when you put a scale for the single parts, then if you put a small scale, then the smaller ones really end up almost not visible on the drawing. But if you put a large one, then the big one. So, for example, in this column, you have a comparatively much larger base plate over there, and then you've got some very small plates as well. And you want to give a general. So, in general, over here, the scale is 1:5. But you want to make this one 1:10 and maybe this one a bit smaller as well. but you can't have multiple scales because you don't know which one is which. So what we've added over here as a feature, so this one is P2, the part mark. So we've added a new feature in this version in which you can actually go inside and specify single part scale override. So you could say, although everything else is at a scale of 1:5, but I want P2 to be at a scale of 1:10. And you could continue with maybe P168. So let's do this one first. If I say OK, and if I say execute, you will see that that big plate is now suddenly turned into a smaller plate, and everything else is the same. If you wanted to, if these ones are bothering you as well, so P167 is bothering you and want to make it slightly smaller, as is 168, but not as small as this. So what you could do is 167 and 168, you could just go back in there into the settings, and right next to it, you could say P167 with a scale of 7 and P168 also with a scale of 7, like that. And when you say execute, the two plates or these ones are also made with smaller. So you have control over individual scales of single parts while also having an overall scale for the single parts. And once you've done that, then you can go ahead and do your further modifications if needed. Another minor feature which we've added is that previously, while you could create custom templates for the US and Imperial units environment in which you could create your material lists in those units, now we have also added, we've also modified the built-in material lists and bolt lists, etc., to reflect Imperial units, as you can see. Similarly, another feature which we've added is previously, for example, if you had selected a profile in the drawings module, you could right click and say create view, and you could create all the views of the profile inside a particular drawing. Let's say you did not have the front view or the left view of a profile, you could just add it. You could do the same with plates as well. Now we've added so for the plates, we only had the option of creating the top view. Now we've added the bottom view as well. So sometimes the other direction is needed. And importantly, we have added the same option for any generic solid which you might have in your drawing. So all the top, below, left, right, front, and back views have been added, and you can just click on it, and you will get an additional view which you can then annotate or modify or label or put dimensions on and use it in your drawing. Another very useful feature which we have added in this version is the color coding of the viewports. Now, playing around or manually modifying drawings is a time-consuming process, and we want to implement as many features as you want, which makes this process easier for you. Now, in any drawing which you're manipulating, which you're trying to set up manually, there will be assembly views, there will be other views which you've created manually, there could be single part views, and moving them around can be time consuming. Even selecting them can be time consuming. So you see, first of all, there's color coding. All the single part views are yellow. All the main assembly views are of a different color. Any sections you might take manually will be a different color. Any views you import from the model are of a different type. So all you need to do is go and select your viewports entirely like that. And when you click on the viewport option over here, you see that it has grouped them according to their type. For example, if I were to select these, there's 19 single part views. And the moment I click on that, they're selected in the background. There's 3 assembly views, and there's 1 3D which is imported from the model. So it's very useful. You just click on this, for example, the single part views, and if you wanted to just move them to the side, you could just move them to the side like that, knowing that all the other views will be untouched. You've only moved the single parts, and this is quite useful when you're doing the placement of the views of the viewports on the drawing manually. One very nice feature which we have added to this version is related to the dimensions. And as you know, the normal linear dimensions are typically the horizontal dimension the vertical dimension and the aligned dimension, but we've added the fourth option called the isometric dimension. And although this is not a must have as far as steel detailing is concerned, but you see it really gives a lot of aesthetic look to your GA dimensioning. And in particular, if you're in the piping industry, and COMOSYS being a multi-material and multi-purpose program, you can actually even model stuff like that. Your isometric drawings are always dimensioned using isometric type dimensions. So for example, if I were to turn on the joints so that I can snap to them more easily, if I go to the filter and turn on my joints in this building like that, I can go in with my isometric dimension and select this point and this point. And right now it doesn't look good for a reason. If I double click on it, you will see that inside it projects itself on three different planes, either the X plane or the Y plane or the Z plane. So if I choose the Y one in this case, you see it's going to project itself on the Y plane, and in the Z direction, if I do that, it's going to project itself in the Z plane. So I prefer the Y one in this case, like that, and I can select it and I can move it around like that. If I wanted to add another one vertically, let's say from here to here, like that, it automatically projects itself to that one. There's an auto option in there as well. So these are very nice looking dimensions, and they really make your GAs stand out. And sometimes you want to give dimensions in 3D and you want to project them onto certain planes. So with this new option of isometric dimensioning, you will be able to do that. Drawings always require some amount of effort. If it's GA drawings, then a considerable amount of effort might be involved. Even with assembly drawings, sometimes you do a lot of manual cleanup and things like that. So there is effort involved. And it can happen that you delete a drawing accidentally, or you delete a drawing and then some time passes. And after the passage of time, you want to actually kind of undelete or recover that drawing which you had deleted. Now, with this version of COMOSYS, we have added this new recover feature for your deleted drawings, whether they've been deleted recently or immediately before that point, or if they had been deleted earlier or some other day or some time back as well. So, for example, this is a drawing called GA1. If I were to accidentally delete it, for example, so this is GA1. If I were to go in and say delete drawing, it's going to ask me whether do you want to delete. If I say yes, at this point, it's basically gone. And once I save it, then it's gone forever. And now you see GA1 is no longer there. But what we've added, and this could not necessarily happen immediately, maybe tomorrow, the day after, next week, I come in and I recall that this drawing I need it again. So I have, under the other operations over here, if you come over here, we've added this new feature called Recover Deleted Drawings. And if you click on that, it will show you a list of drawings which you have deleted in this model. And you could choose any one of them. I'm going to choose GA1 and say recover. And when you do that, the drawing basically comes back. And when you double click on that, it'll ask you to whether you want to save or not. And once you say save, then the deleted drawing is brought back from the archives, if you will. So this is a handy new feature which you can use. With that, we come to the end of this presentation. All that you saw was added in just the last 6 months. Other softwares have annual releases which offer half of what we offer. We realize the decision is a difficult one, but we also realize that the market is desperately looking for powerful alternatives. Please feel free to contact us or our resellers and let us help you make the transition. As always, we will be contacting some lucky ones among you who attended this entire webinar with very special promotional offers. So keep an eye on your emails. Now, let's take a few questions, if there are any.